Good turnout today. Fantastic. Well, thanks everybody coming out today for the August meeting after a 1-month hiatus for summer break. We're back now in August for OWASP San Antonio. We got a great talk here today. But first, before we jump into that, I want to put Matt Tesoro on the spot as he's eating pizza. We have OWASP royalty here today. I think that's what your job is. Sure, that sounds good. Matt is now, you're full-time now with OWASP, right? Which is awesome, and I think you're coming in to do some really important stuff that is very much overdue. So maybe you want to talk just a little bit about what you're doing for OWASP?
Yeah, I don't forget the technical title. I have some title of some sort, whatever it is. But the whole thing was, there hasn't been a necessarily technical person at OWASP kind of ever. There's been a lot of volunteers doing technical stuff kind of on the side and when you can control people. But now I'm in to do that full time. So in theory, I'm supposed to work only on the project, the domain, but honestly, it touches so many other things that I'll do a lot of fixing and automation. And like there's an example, every quarter we do a health check on our existing projects. And the poor PM that does it right now is going click down into GitHub and finding the last commit and clicking around and getting this and putting it in a spreadsheet. And it's all stuff that I could write against the GitHub API and pull automatically. They just haven't had the knowledge to know that was even an option. When I told Claudia about that, she was like, "Oh, you can do that?" I'm like, "Oh, yeah, I can do that. What the hell? Do you want to go click around and copy and paste out of a web browser? Like, let's make this better." So.
Yeah. Very cool. Well, great to have you at OWASP. Great to have you reasonably local here.
Yeah, not too bad.
Very cool. So today, you guys are going to be talking about data exfiltration through DNS lookups. And our speakers are Nolan Berry, Tony. Okay, Tony Basil. All right, okay, good. And Corey Schwartz. Very good. Okay. Nolan is a Linux systems engineer and network operations DNS on the network operations DNS infrastructure team at Rackspace. Tony is a security engineer on the network operations DDoS team at Rackspace, and Corey is a Linux operations engineer at the Rackspace cloud storage team. So thank you guys very much. I think this is straight from DEF CON, isn't it? Yep. So that is fantastic that we can get guys like you in to present here today. Without further ado, go for it.
All right, so this is our talk. We just gave it last month at DEF CON, and the only thing that's really changed since then is probably the interesting point that the equation group leaked that shows that these are actively being used pretty much in the same way that we do a live demo of and show botnet command and control structures and DNS lookup exfiltration through DNS. So we know that this is a real threat that's out there and being used. All right. So DNS, how is it used and what is it? I'll just gloss over fairly quickly. DNS, most people are probably pretty familiar with it. Really, the main thing that we focus on here is usually you have caches. If a cache doesn't have that data cached, it goes ahead and does a lookup to an authoritative name server, and that will come into play later. But that's for the most part what you need to know. It's just the way that a computer, connects FQDNs to IPs. Right. And so, why is DNS a problem? Well, DNS is pretty much required in most server environments. You're going to allow DNS port 53 through firewalls, even if you only allow it to your local caches. You're still going to allow it to hit that cache, and if that cache doesn't have it, it's going to go out to the auth. So this is a vector that's almost always open, and it's very rarely monitored. Most environments just don't monitor DNS requests with that much scrutiny because there's either so much of it or it's just something they don't even think about. And I know, for one example, someone came up to me after my presentation at Rackspace and said, just so you know, your talk wouldn't work. I used to work security at the financial sector, and what we did is we would hold back every forward lookup from our caches and manually check them. And I asked him how much latency that added to his lookups, and he said about 2 weeks. So that was the only security measure he could think of, was manually holding back DNS lookups and manually approving them. So, wow. So the source sends, the way this works in our method is basically, DNS tunneling and DNS exfiltration is not new, but the way we're doing it is we are sending base64 encoded chunks of data as subdomains of a domain that we're authoritative for. So basically, we base64 encode data, break it up into DNS chunks, and then we forward that on to a domain that we're authoritated for. So we use the caching server to basically route our data for us, and then our server itself is not actually a DNS server. It's actually a listening device on 53 that stitches the packets back together, and it also crafts and sends a fake response. So it looks, if you're running TCP dump, like a valid DNS lookup with a response and everything like that. Because one of the primary ways to look for this kind of thing is going to be a spike in NICS domain lookups, or just a lot of weird lookups. But if you get into the crafting of the base64 encoded domain, it looks a lot like maybe something a CDN would use or like a cloud database would use. So it's not that different. I mean, it's a little strange, but it's not that odd to see. And if you look at it, and you will be able to see a record return and responses that we have made. All right, so this is kind of just a quick once over of how this actually works. Server is compromised. So all of this, basically the problem here that we are going over is it assumes you already have root on the server and you have a lot of data and you need to get it out in a very low key without raising any alarm bells. You need to get data out. So firewall rules already allow port 53 for DNS. And we send the encoded DNS, which would look something like that. It would go to the cache, or well, in this case, we're pointing it directly at a DNS server that we know, like a dig at whatever. And that would pull it out, and you could just parse it out of the logs or something like that. But you can do it in a better way by hitting the cache, forcing the cache to do a forward lookup. And so then we got into going into detection and mitigation, which at first we thought would be a lot easier. And then we realized just how difficult of a problem this is and how hard it is to actually detect, or at least mitigate. It's easy to detect, but it's almost impossible to prevent before it happens. So you can configure internal DNS server for all, and then block access based on IP reputation. However, that's always after the fact for the most part. Packet analysis with an IDS. That's great and all, but like malicious actors can easily just go buy a new domain and switch over to that, or get a new block of IPs and just switch to that. So the whole blacklist option is not really all that viable when you can just have disposable IP blocks or disposable domains that you can just cycle through. So you can configure snort or bro.
What about Lightsaber and Stealthwatch?
You can use a lot of these, but almost all of them, you can do big data analytics, and that's really the only good pattern recognition that you can get into. However, most of these things are after the fact. You'll see that something happened, and you can figure out what happened, but you can't prevent it from happening.
True.
For the most part.
React.
Yeah, reactive, not proactive.
There are heuristics that like Stealthwatch has, and I don't know Lightsaber, but there are ways of detecting it. But I mean, that's not the firewall blocking it. It's nothing that's taking action in line in path.
No, we set them up and stuff. So NetFlow collects the data, so it detects it, right? So but the problem is I've never seen these kind of anomalies, right? I mean, I've seen some weird things the minute day when you put them in. Yeah. So I was just wondering, like, now I want to go back and look in my lab about what can it do, because that's pretty cool stuff.
Yeah. Well, we're going to do a live demo, and so you'll see what it looks like.
Lightsaber's the same.
Like, all these scripts are on GitHub too, so y'all can play with
Okay.
this. Yeah.
Awesome.
Yeah. And we've actually had a couple people reach out to us and want to use our software for red team testing, and we've provided that to them. So. Yeah, so this is just another example where you've compromised a database server, you've dumped it out into an SQL file, and you need to get it out of the environment. So you send the encoded DNS query to the internal server, and then that will go ahead and forward it out. And that will bypass your firewall, your router, and I don't know, at the scale that I know I work at, a couple thousand queries is not going to raise any eyebrows. Yeah. So, and most people don't even look. All right, detection mitigation, again, IP reputation or based on geolocation or reputation. I mean, that's difficult, but especially when you're a global company. DNS RPZ is a really awesome new feature that I know we employed it. We were, I think, the largest first customer of ISC to deploy it. And in 24 hours, we blocked, I believe, 8.5 million malicious DNS lookups and took down a lot of botnets and also outbound DDoS attacks, which was pretty cool. But we unfortunately had to pull the plug on that project, which we're going to be relaunching soon, due to some bind bugs that we found based on our size. Basically, Spamhaus was doing AXFRs 1 a second of like 8 million zones, and it ended up crashing a bunch of bind servers. But we got that resolved, and we're going to be launching that again. But that is a huge tool. It's basically a malicious. It's like a reputation for zone names and DNS lookups, and you can change the response. What I'm interested in doing with it is actually, you can also redirect it and not just throw NICS domains, but you can actually forward that lookup to a different IP. So I want to forward it to a honeypot that pops a ticket and sends it to a customer and tells them, hey, look at your stuff.
That's cool.
The DNS analysis with big data analytics, you have like Splunk, Hadoop, Elasticsearch, Cassandra, all great tools. And Tony will be doing a demo of some big data stuff that we're doing with Kibana. And with that, we're going to let Corey do what I think is the coolest part of this, the live demo showing exactly how this tool works. It's base64 encoded, 200 bytes at a time, and DNS lookup to an auth server. I'll let Corey talk about his tool.
Yeah. All right. It did phrasing. So
Yeah.
We've done this type of testing before. What they call
just turn on.
it's called covert channel stuff, where people trying to get stuff out. They assume that something's compromised. They're trying to get their whatever out without being detected.
That's how it works.
Usually it's been over port 80 or web traffic. This is over domain name service, which is in each has to be open in order to be
In that
looked up.
case,
So
I'll
it's
do
pretty
it
cool.
second screen. Do it that way.
There we go.
Okay. It's a little better. Okay, so I just have some diagrams that sort of go along with what I'm saying, just so it's easier to follow along, but this is going to be mostly live demo. So this is supposed to represent just typical caching, forwarding DNS server that everybody knows and loves. End user makes a request, goes to their local DNS server that's either at their business or at their home. If it's in the cache, it responds, but usually if it's an unknown domain, it'll look up the authoritative name server, and that will push down back to the user. The only thing that we want to do is we want to replace all these components with, well, it's the same components. This local DNS server is the same, this user is the same, but we replace this authoritative name server with one that we have control over. So with that, I just want to show you. Interesting. Might have to go back to. Okay. All right. Well, this is what it's going to have to be. Okay. So I have this environment done in virtual. So if I SSH into this real DNS.com, everything has .com because it was DevCon. So
And we also didn't really want to taint actual internet records with this stuff. We
Yeah.
did have it working on cloud servers. We actually moved an ISO file from one data center to another using this. It took quite a while. The speed was, I don't even think it was a K per second. It's
So
pretty slow.
yeah, so this is actually just a fully functioning, properly configured domain server that runs binds. The only thing is I've got a zone configured. Since this was made for DEFCON, anything that ends in the domain def.con gets forwarded to this fake DNS, this fake authoritative DNS server. But consider this to be the same as like you bought a domain, you just configured the NS server for it. But it is a fully functioning DNS server, and on my laptop, I'm using this IP. I'm using the IP of the functional DNS server as my DNS server. So all DNS requests get passed to this, and it's supposed to be a fully functioning caching domain server. So the real good stuff happens on this authoritative server. Fake DNS. There we go. Okay, so what I've got on here, SS. Notice there's nothing listed on port 53 right now, but I have this program that I've written, Exfiltrate, and you notice that it's actually the program that listens on port 53. That's cool. Oh, there we go. So Exfiltrate is now listening on port 53, just because I think you guys would probably be interested. It's actually quite simple. Like that's it. It's a DNS server. It handles MX records and A records. So A records basically. I'll just show you how it works rather than trying to read code to you. But so the idea is I can do a dig on something.dev.com. So I exfiltrate data by using the subdomain as base64 encoding data and then using that as the subdomain. So let's say I wanted to send like the word hello. That's what it is in base64. I would dig that word, give it a file name, and on my laptop, you can see that it actually responds. It gave me I don't know what that's about, but it gives me a response. It all looks legitimate, but on the fake DNS server though, I have this file that's been created, and the content of that file is the exfiltrated data. So obviously, you're not going to be able to convince somebody to do that. That would be pretty odd if that was the only way that you could use it. So I've written a couple of clients. Python, let's do that one. So let's say I want to send something that's a little bit larger. The DNS packet structure has limitations, like you can only have certain links for the size of domains. You can have only certain links for the total number of records. You could probably play around with it a little bit differently than what we did, but this is just simple. So, like let's say I want to send something like my password file. Python C. Yeah. There we go. Okay. Well, basically the idea is if there's a file that's larger than what you could send in a single packet, you could basically just break up the file into smaller segments and then send those segments. So I want to get into how that might actually be used as part of a real attack. So switch back over here, just so I can show what we're talking about. Okay, explain. Okay, so. The first thing I want to demonstrate is hacking end users. A lot of times I've seen demonstrations of this that they actually hack servers with it. You somehow have to get data off the server, and so you break up data and exfiltrate data. That assumes that you've already hacked something though.
I want to demonstrate something a little bit different. We're going to hack a client using a DNS, using MX records. So let's say you've done this this DNS request. There it is. And you get this IP back. It's 192. Let's say that's actually a website. Oh, come on. There we go. Okay. Yeah, this is our website. It looks completely legit, as you can see. What as so often happens, they have some part of the website that lets you run a game or something. Oh, I just want to run it, not save it. Okay. Oh, here we go. I thought they were running twice now. I'll quit. There we go. Okay, I'll make this a little bit bigger. So this is a Java application. Of course, you should substitute this with some like legitimate looking Java applications, but what this is actually doing is every few seconds it makes an MX request. What is the MX record for def.com? And the server responds and gives the MX record back. How this application interprets the MX record is as a command. So to a network operator, that looks like completely legitimate. If somebody wants to send an email, that happens all the time. Nothing to look at, nothing to worry about. And this, you could get a pretty good, presumably you could get a good install base of this application if this looked like something that was legitimate. And then one day, your hackers come back and they send something to it. I've actually got it, so if I send it into the con file, CMD, if I send it into the command file, then that becomes a command, which again, I just sent that using DNS. On the server, I have now a file that's named CMD that has the word hello in it. Every 30 seconds, our user is polling this, and it's now received the word hello. I don't have that as a command that the Java application actually wants to work with, but let's send something even a little bit more risky. Let's send. Right? Let's base 64.9. Let's base 64.ssh ID RSA and send that to command. So if I look at the server, this DNS server, in the word command, I've got .ssh ID RSA as the last thing that it's the last command to send. That's like the current command. So I can see that my web application has already received that command, .ssh ID RSA, and without even prompting the user, it's already taken action. If I go back over here, it was a little bit too fast for me, but I've already got this 192.168 web app, and that is in fact my private SSH. Don't worry, I changed my SSH before I did this. So, but I could cause it to send anything I want, and no one would notice probably. In fact, even if def.con had a lot of malicious activity, and you put a block, like I no longer want somebody to connect to this website, so I block port 80. If somebody's already running an application, blocking port 80 to this domain is not going to block anything because we're using the DNS to do the routing.
And over TCP dump, you do see standard looking bidirectional traffic because our fake DNS server spoofs and sends a fake A record response.
Yeah, I can show that right now.
One of the strategies you can do statistical analysis to see if there's a spike in NX domains. If you go get authoritative name services, I don't know what the hell it is, that's not a real domain. So if you were sending a bunch of fake stuff up, and you don't have the server configured like we do, then you're going to get that spike. So we favored that by sending every single time it sends a query, it sends a response back with, in our case, a legitimate IP. So that way, if us security guys are looking at it and we decided to go see what that IP was, well, we're actually perpetuating the issue and becoming part of the bot just by checking
You land
if
where
that
the
was
Java
legitimate.
file is, then you click on it, and you're owned. And that's what those MX record lookups are.
Yeah, here you can see the Java application is actually doing MX records periodically and saying what is the MX record for def.con, and then it responds and it says, oh, the MX record for that is this, which is like the file name in base 64 base 64. So I can change that. Maybe I don't want. Maybe I'm not interested in RSA ID RSA before I've already got that. So maybe I want my password file now. So I'll just set that. And the next time you notice, now I've got a lot more DNS traffic because there was a new command. So the Java application said, oh, I need to send the password file now, which it does what I said about breaking it up into little chunks and sends it in the form of like a series of A records. So you can see like all these unusual looking A records that are being sent. Like what is that? It's a base 64 encoded piece of my password file, which
strikes me as something a human would have zero difficulty picking out of a log. The machine would just never be able to see it.
sure, but
I mean, even with like when I look at logs, we have about 140,000 queries a second, and when I monitor it, we also have things like cloud databases, and they append hashes to the beginning of the subdomain, which looks fairly similar to that. And it uses the DNS API to just update it and make changes. So it uses DNS hashes as subdomains so it kind of looks like a cloud service almost.
yeah, there are legitimate services that use what looks like hashes as subdomains. It might not look like a domain that you would want to visit or something, but
Like a CDN, like Akamai or something like that.
yeah, it might not raise an eyebrow, and especially if you're not looking at it, then
I mean, you could probably
The problem would raise it. The only way to catch it would be like you'd see like, okay, Akamai's doing that, Google's doing that, and oh, who's these new guys, def.com?
And more importantly, it's after the fact. It's already happened.
Yeah, you not even see 8,000 queries go out to this one domain.
yeah. The point is that you maybe you bought this domain and it seems legitimate, and then one day you just turn it on, and all of a sudden everybody's sending you their SSH keys and password files.
Or just swap 2 characters in the word Akamai, so it's a typo. And then, if you're not really looking for it.
Yeah,
So-
maybe you own Amakai.com.
Some antivirus will take the files and hash them and then send them to their authoritative name servers with the hash to see if they're matching what's in the system. Even antivirus uses it for legitimate
Signature.
reasons.
And this won't fire off any red flags on signature based, since we're base 64 encoding it, unless you have something that base 64 decodes all your traffic, which is kind of high intensity. Not impossible, but
So given the limitations of DNS, is there any way is there any, it's great to know it after the fact, but
I mean, really, not really. I mean, so like I said, there was that guy who said he worked in finance who they held back all forward DNS lookups for a long time and then manually approved them. That's really one of the only main ways to do it, and it's really not practical. It depends on your environment. If you have an environment of like controllers in a manufacturing plant or something like that, where you know every single call that's going to be made, and you don't have to allow it to make any forward lookups. But if you have something like a web hosting company where forward lookups are the business that you're in,
and so
you
there's
can't.
no way you could make a recommendation to improve the protocol either, right?
I mean,
Organizations that try to do this, they usually implement some sort of whitelist.
Yeah,
I used to work DoD, and
which
we had a
is
whitelist.
It's not going to work.
but you could just change your, whitelisting is really the only thing you have, but you can always just get a new domain every day, or every hour, or every minute. It's not hard.
So really, it's just big data and analytics to understand.
Yeah, and that's after the
context,
fact
and that's
anyways,
after
it's
the-
reactive.
Okay, great.
You can see how you got owned, but not really do much to prevent it.
That's some solace, though, isn't it?
Yeah, I mean, least you know it's.
So a piece of the onion layer.
Yeah. And one of the ones that might be more interesting to the web app folks here is Corey does a demo of SQL injection, forcing it.
Yeah, this is the second part of the demo. So in this case, we've got a web server here. They've got databases that are on a private network. They're security conscious. They don't just allow SSH into their databases. But it is typically the case that some DNS server will have access to the internet, even behind the DMZ. Even these private DNS servers back here may use a DNS server that has internet access. Let's just say, like, that's often the case, right? So this is what an attack looks like if there's some sort of exploit. In this case, I'm using a SQL injection attack just because it's easy to understand. But so an attacker, someone on the internet, has access to the web server. They don't have access to the databases because there's firewalls and stuff that prevent that. But they can still send commands to the database by issuing calls through the web server, and the database will respond. If I can convince the database to make DNS requests, then I can actually make it do some pretty nasty stuff. So this is our database right here. We've got on the same website, Meet the Team. I've got people on. Let me just close this Java thing. It's no longer necessary. People on the team. I can click on us, and it gives some information about us. Yeah, Nolan's 101. So
Aged well.
Congratulations. Okay, so in this case, yeah, we've got some DNS lookup. We're passing this string to the web server, which will do some sort of translation to figure out what DNS request we want to call. And the DNS server responds with this information, but as is so often the case, there's information in the database that you would not typically display. In this case, I just put like some phone numbers, but it could be credit card information related to somebody's account or something. But and this I put this is the PHP that's actually running on the web server, just so you can see how bad it is. Of course, I'm doing this intentionally for the demonstration, but there's definitely code out there that exists that looks like this. So here's what we can do. I wasn't brave enough to try to do SQL injection without copying and pasting, so there we go.
I'll give you a couple recommended sites.
Okay, so here we're going to just do the hello world of the SQL injection. I put the actual query that I'm passing right here. You can see I'm doing select Tony, and then it's SQL injection attack. So I added on also select by host name hello base64. So if I go and look at the database or our fake DNS server, I've got now a file here that has SQL on it. There we go, SQL. Okay, and the word hello was sent to us. Let's remove all these files. Okay, so step it up a notch. Here we're going to not just send the word hello, we're going to actually send something that's not normally shown on the web page. So paste that in. Okay, so that's a little bit more complicated, but I'm selecting this, in this case, the social security number from people where name is Tony, cast it as varchar because it's an integer, and then encode it as base64 and send it on to the site. I look at the site. Sure enough, that should be in fact what Tony's social security number was, right? forever compromised. Okay, and this one was what I felt like was the interesting one. Before I do that, I'm going to erase the file. But okay, so this one's actually the interesting one. I picked Postgres specifically because it was possible to do this, but Postgres is my database. It has a function called read binary file, so I can actually read the configuration file, which is in the data directory. If you're not familiar with Postgres, this is read postgres.conf, start from byte 0, read 30 bytes, and then again, just base 64 encode it and send it on. So let me just do a tail dash.
And 30 bytes is just to keep it quiet because that's the size
Yeah,
of
so
a DNS packet.
that's what I got so far. It's like the first part of the file. But I can wait a little bit. I don't want to set off too many alarm bells. And then now I'll start at byte 30.
We used to 30, we 230.
No, it's 30 and then 30 more bytes.
Oh, okay,
So
start that and how much you increment.
So now I have the next 30 bytes. I can do this over and over and over again. Just, do 60, do 90.
We could probably script that and make it.
Oh yeah, totally. Yeah, you could do this in curl and a for loop if you don't want to do it slowly or do it like this. But okay, so we should have a few bytes now, and you go in. It's reading the Postgres configuration file, 30 bytes at a time, and it's just sending it to me. And this all happens even though maybe the admins know that def.con is some malicious thing. They were like, oh, block port 80, block port 443. Don't allow outbound connections from the database at all. But maybe DNS is allowed. So
Right. Most of the stuff could get stopped by Green SQL, WAFs, next-gen firewalls, loan algorithm. We'll pick it all up.
yeah, in order to do this, there would have
Yeah,
to be
you have to be
a
like
litany of
real-
other security flaws
Yeah.
too. The SQL injection would have to be possible.
But it's still so effective in today's times, right? I mean, it depends on where you most of the times people put all their defenses north-south. They don't even look when it comes into they don't not checking east-west attacks, right? And that's right now where people are beefing up. So those are the things like, oh, your attacks are very efficient in most of 90% of the companies in San Antonio. It's just north-south right now. It's hard to get through because you got WAFs and next-gens. And you try to beat that credit card data out, you got something called loan algorithm, which detects passports, social security, credit card numbers. So as soon as you pop it and you decrypt the SSL, because I'm assuming you guys are going to run this stuff over SSL, right?
Sure.
If you were doing it, because
Yeah.
clear text, you get popped quick.
Yeah.
Over SSL, as long as you got those defenses set up to watch that SSL, you could catch all that credit card before. Right when it's detected, it's told to drop it.
Yeah, but it's
But
usually
basic
watching.
SQL.
If I'm looking for a social security number or a foot and the response of the content.
Is this still on the
Then-
DNS or is this on
This is
web?
all DNS.
Yeah, this is.
Oh, it's still DNS?
Yeah,
Okay, I got
this
no
is still
time.
DNS.
I'm sorry, because I thought you switched it to HTTP.
Yeah,
You were saying over
I'm
HTTP.
instructing the database server to make a DNS recall.
Yeah, I like them
And
for
it's
that.
been
I'm
base
doing
64 encoded.
yeah, get host by name of this domain. So the stuff that gets responded to me if you're doing content matching, that it looks odd, but I don't know, maybe that's my
Nobody would alert off of that.
Not a DNS.
Not a DNS.
So now there's two big holes right now in
Nobody.
security. It's DNS and voice security.
Yeah.
So now they're tying in voice over mobile apps, and we're finding out people are treating stuff getting into the call managers through that.
And we
And we're like,
launched a call
we got
Vixie,
nothing on the market for that stuff.
And they just launched a new service called from Farsight Security.
Yeah.
And Vixie was talking about their new service. I think they're calling it Sentry, or they just changed the name or something. But it should be a big step up for DNS security. But it's essentially also just a blacklist.
It's a big DNS whitelist.
Yeah.
But
So
then,
that's
yeah.
the only thing effective against these kind of attacks is
That's-
whitelist?
I mean, yeah, that's the tough part. Or just holding back forward lookups and waiting and then being.
Well, I mean, if you didn't want a lot of data to transfer out, you could probably stop at, say, a few thousand requests, because, I mean, you're not getting much data out in 1,000 requests even. I mean, you say you guys transferred an ISO over it, that's got to be
Yeah.
like millions of requests that,
Yeah.
that went that
Right.
way, right? So,
Let it off.
hopefully your reports would that would get to the top. But
So we thought about that, and we thought about how we could make. We kept it simple for this demonstration, but you could easily spread this across multiple domains. Add another subdomain that's a hash for a piece, and basically you're writing BitTorrent over DNS at that point. And that way, since it's UDP, we're also concerned about transfers stopping in the middle and then not being retransmitted and having a corrupt file because of one drop packet. And so you would have to be able to break things up, chunk it out into 1 meg bits, and then run a hash on it. And then you could have multiple authoritative domains all going to the same server that then pieces it back together using the hash table.
have you found, you said antivirus uses something that looks similar to this in order to transmit the hash to the file. Have you found anybody else using this legitimately to transfer binary data in the wild? Because that would be the interesting thing, is studying. You guys have a large enough DNS infrastructure.
Yeah.
Have you looked at DNS cat?
Yeah, so I know one person came to us and told us they wanted to use us instead of DNS cat because ours was able to do low and slow because you could add sleep timers in and you could have more control over it.
The other thing too is like you mentioned on one of the diagrams earlier, in an environment where you don't have direct access to 53 out, you only have a caching's access.
But the cache will usually route out, right?
Yeah,
right.
The cache will forward lookups.
Right, if it doesn't have a record, so it has to be like a new domain every time. So y'all's technique is different because it's querying a new subdomain every time, so it has to perform that outbound lookup,
Yeah,
right?
it's always not cached.
Right. So it's always not cached. Whereas some of the other ones out there, there's a beacon is one. There's a few other ones.
Iodine, but those are all more tunneling. This is more just straight lookups.
Exfiltration, yeah, and that makes sense because you're not getting a lot of commands back. You're getting legitimate data.
Yeah, and this
back, which
looks
is
legit.
harder to detect.
Yeah.
Yeah. Well, what we're doing, I put this diagram here just in case somebody wanted to see it.
Yeah, he wrote the first version of this tool. He didn't know Python had a DNS library, so he completely wrote listening. It would scrape out packets based on their bytecode.
That hourly rate.
Yeah, that's manly, right there.
So yeah, this is basically the packet format. You make a request and then the server will respond. Basically, when you do a request, you include all these sections up to the question count, and then you add your question, and then the response always includes all of those fields. This is just a header that shows the counts. But then, so here's the question. The question is usually a record or quad A. Each one of those has different requirements, and you could play with that and use different types of requests that have different size constraints. We went with just A records because that's the normalist record and the one that is probably least likely to cause suspicion. But yeah, you could use TXT records or something too without any issue. This is what the response looks like. You basically copy. You copy the question in this name format, or provide a reference to it, and then you have our data, which technically could be any length. You just specify the length of the data that you want to send, and then you just send it. All we're doing is we're just picking out those fields and just applying base 64 as an encoding around it, and we're just using the DNS existing infrastructure for routing purposes.
So would you run into a problem with the local DNS server caching records if you hit a collision on your encoding?
Yeah, like if you sent hello twice, and like you could drop.
I thought about that. I set the TTL on all mine to 0, but I feel like that would also be probably very unlikely, unless you're just sending the same, like exfiltrating the same data over and over.
Types of files.
Yeah.
Well, you probably have the boundaries would line up to that.
Yeah.
You could see a world where you're sending a million.
To overcome that, I just set the TTL to 0 always on the server side. It's kind of doing it in reverse. Like you make a request, but the request is actually sending data. So on the server side, it sends the response back with just bogus information by just setting the TTL to 0 to try to ask the caches not to cache it. This is what it looks like if you do it manually. Yeah, so don't do that. That's crazy.
No, do this. This is how you learn how DNS works. Right?
Yeah, that's right.
Nobody this room knows as much about DNS as you.
Because like I've seen people do similar stuff, but just with scripts and not have a whole framework and stuff like that. You know, like what you don't have to do everything manually, or
Yeah.
if you don't have a certain library on the target system, this is better because you're not depending on that library to be installed.
Right.
And it's all self-contained. That's pretty cool.
Yeah, and the Java one is the same. Like, if you actually want to actually see that.
How many hours did that take you?
Not too long. But.
It was crazy because every time I'd see Corey, he'd be like, "Hey man, I was just working on this last night." We basically pounded all this out in like an afternoon at a coffee shop, and then every time I would see Corey, he would be like, "Hey, I added botnet command and control structures to it."
Here's what came to my mind. Watching this through, I was thinking, like, exfiltrating data, you can get little chunks out pretty easily. The minute you try to do something big, in theory, somebody could cache it, right?
Mm-hmm.
What if you built into, say, a web page that you had, say, an image algorithm that you could get a browser to trigger that lookup?
Yeah.
So now you're selecting for users that you've tricked somebody into visiting your ad network, and now you're selecting users and can exfiltrate some piece of the browser.
Yeah.
So now you can just select.
Or like
which
some kind of
side
nasty
you're targeting.
JavaScript that would just sweep through someone's phone, or I don't know. You can set it to just sweep and be like, "Hey, upload all the .doc files," or stuff like that.
So like here's that Java application that uploads the files. Like once it's received a command and then uploads the file. This is the method that does that, and it's pretty easy. Just read in 30 bytes and then do and then send it. And send is just do an A record lookup, like get host by name.
Has anyone tried like just base 64 or searching for like base 64-ish strings in the queries? I don't know, like, because y'all would know better than anyone probably like what type of processing power, how much volume. So I can't even
We haven't
imagine.
tried. You mean like on the fly base 64?
Just looking like for base 64 strings, because usually they have kind of a format, right?
Like parse your network words.
Yeah.
Right, you know.
But you could not use base 64, just use
something else.
else.
Right, yeah. That you wouldn't catch if it was
Yeah,
encrypted.
you could just do an
or-
offset of a certain
And plus,
number.
base 64, you could encode binary data.
Right, and then you
that you might,
decode it,
even if you
still-
decoded it, you still might
You
know.
don't know what it is.
McAfee did a presentation last year where they caught a DNS tunnel that half of the 300 bytes that we have was a sequence number. The other half of it was an encoded RSA key and then the data. So even if you did find it, it's encoded and it's encrypted.
But you'd still find, yeah,
So
something.
you see something's going on.
Something's going on, but
But
I'm not
what?
sure what. But because like, from what I understand, correct me if I'm wrong, you have to use base 64 encoding with DNS queries because if not, it would break with certain special characters. For example, binary content, right?
That helps, yeah.
So I would think even if
Also,
even if-
fingerprinting for IDSs, it's nice.
So even if there's encryption being used or something, like, it seems like base 64 would kind of be a common denominator.
You gotta get it back to text. So any way of getting it back to text
Yeah,
is what they're
it's
saying.
like the
So you
most-
could base 64 encode it, or you could, maybe you transform it a little bit before you base 64
Yeah.
encode it.
You just
Right.
use a random seed key
Hey,
you
David.
only have, and
Right.
then.
But even still, so if you found base 64 encoded data being passed around, it would kind of be like a red flag to look at.
McAfee uses it.
What?
or
Yeah,
uses it.
McAfee antivirus
What-
uses it legitimately for their
When we were at the
updating.
party, what were you saying? When you were at the party, you said you were going to use base 64, and I said, well, I could see it if you were doing it. You remember what we were talking about? I can't remember.
I don't know, I mean, so like that.
Right.
you know,
Yeah.
And like our
there's so
cloud
much stuff,
databases
and
was
it works really well
similar.
because, this is the exact problem that you guys are talking about,
Go to your section.
but,
Well, we're going to do one more section here and show some detection methods with the big data stuff that Tony has.
But just correct me, there's a tool that I didn't manage, but like Infoblox. Infoblox already has
Yeah.
signature-based
Yeah, so it's-
transactions, right?
Yeah.
So they can see that those scripts are running or that the abnormality of DNS is coming through.
Yeah.
So,
But even then, you're detecting it
In base 64.
either as it's happening or after. it's
right,
already
well,
happened.
as it's happening, right? If it didn't happen, it wouldn't catch it, but
Right.
but as it's happening,
It's not like a firewall, basically.
right. But I thought Infoblox was already looking into that.
Yeah, I've actually talked with the Infoblox guys about
Okay.
this. It's actually kind of part of what piqued my interest was hearing about a case that they were brought in on to work.
Okay.
There was a major retailer that got compromised and had credit cards stolen using the credit cards were the subdomains. It wasn't this dramatic, but
That's right.
yeah. And a company, I don't know if it's public, but it was their credit cards got stolen as subdomains of a domain the hacker was authoritative for, and then they parsed it out of their logs, and it was millions of credit cards. And that's what piqued my interest in this method, and so that's how I kind of went down the rabbit hole on this.
Got it. Yeah, it's really cool. I think you guys are in a really unique position to not only see what's being used out there, but also potentially solve it somehow.
Yeah.
It's a really, really good way, like you said, for red teams and stuff like that to use.
Yeah, blue teams hate it.
Yeah.
Because we're like, if you guys do it, we figure it out in the labs. We're like, I got nothing for that. Right now.
Rackspace has already come up to me to ask me to help develop some of the internal flags for our red team, blue team, capture the flags and stuff. And so I'm going to be working on that too.
Making hosts.
Yeah, it's going to be fun.
So now that you guys are thoroughly scared, I'm going to run through how we can combine a couple of applications together to create a big data stack that allows us to detect it. This is the Elasticsearch database, which is a great key value store using Logstash to just read through files. PacketBeats is actually a new part of the Elastic Stack, and it's like a PCAP, but what it'll do is it'll take the data inside of the packet, decode it based on whatever structure you have, like if it's a HTTP protocol or in this case DNS, and it actually maps the header field to the value so that way you can pipe it straight into Elasticsearch's key value pairs. Then we have a Kibana dashboard which uses Lucene queries to look over the dashboard, so we can say, show me all things that have query A, show me things that have top talker, or in our case, we're going to look for like the top fully qualified domain names based on uniqueness. This is just a dashboard real quick that we busted out. Shows the source IP, dest IP, and what type of method we're doing. In this case, it was his queries to A records. Everything you're seeing on the right-hand side are completely legitimate domains that were going out of my server naturally. So yahoo.com, gmail.com, this is just white noise that I had running on the server. This server is going to act as the client, but if you had this centralized point, our recommendation is to host your own internal DNS server, and then on your own internal DNS server you would run this, so that way you can actually watch all the queries and responses and be able to go back historically, or you can actually configure beats. Actually, you can configure bro IDS to detect the tunnel and pipe it straight into Elasticsearch, which then would fire off an alert and you can get an email.
And we use span ports to keep it out of line, so it's not an inline point of failure, but a good span port that just sniffs the traffic you can monitor.
So if we were to just look at what normal traffic looked like based on the number of unique, fully qualified domain names on the top, you can see there's 5 unique FQDNs. If we sort those FQDNs by the size or the number of bytes, you can see again it's fairly stable. This is our legitimate traffic. And if we sorted, or if we looked for who is the host that we're sending all this data to, all of those queries are going to the hosting provider's name servers. That's Nolan's name server. So this right here is looking at that name server. So you'll actually see it here in a second where it'll separate the different IPs that we're sending. But these are the unique FQDN that it's actually sending. So in the top right, you'll see that it's matching what we saw on that first screen. So through the power of the internet and Corey's wicked DNS tool, we decided to send some incredibly sensitive files over the internet. As we sent them across the internet, we were able to get a pattern show up. And in this case, we've got the unique FQDNs jumped from 5 to 8,000 unique FQDNs. And then the byte size went from, again, about, what was it, like 15 bytes to over 800 bytes per second. If we run down this path again, we say, hey, show me the top 10 IP addresses that have unique FQDNs, and look, there's that rogue server that we're sending all this data to. Now if we stack those servers against each other and sort by unique FQDN, again, our stable state is on the top, that's our control, and there are your tunnels down in the bottom. And with the power of Elasticsearch, you can just zoom right into what you're looking for, and you can actually see every single one of those files that got taken. Same screen again, just zoomed in a little bit more. You can actually see the data that was going across. Stuff on the right side should look familiar. That's the base 64 encoded data as it was going across the line. Finally, something that you can do, you'll notice that the legitimate domains are really small in size usually, whereas the malicious domains, all of them stacked up way more than the others. Just a nice note, the bar on the left is an aggregate of def.com, therefore it's all of the cat or super sensitive fonts level 7. But good test, check the MD5 some, and damn, every single one of them, every single byte sent across the line. We don't have any help checks or validations, but you can modify the script that whenever you send the data to wait for the response back, and that will guarantee data being sent without having to chew in to the amount of data you can put in the subdomain. So that's just a couple of things that you can do as far as detecting it, but again, this is way beyond the point. They're already on your network. They've already...
You had the functional client script working on your laptop,
Yeah.
and it didn't quite work when Corey tried to do it. Can you show that? Because I think that's a pretty good tool.
I think I actually remembered how to do it, but
So this is just showing how it chops up binary files into appropriate sizes and making the request.
this is that script I couldn't get working before.
It's pretty good. Cat loop.
Cat loop.
Hell yeah, y'all. So all it is it's running that find.python script that Corey showed you, and it's iterating through any file in the folder that's named cat. And then it sleeps for 30 seconds, which is what we were talking about. This is not sleeping in between the data it's sending, it's sleeping in between files, so that way the graph shows distinctly what you got. Yeah. That was actually a 3-minute delay, so it looked pretty wicked. We actually ran this right before y'all came in, so I have some fresh data, but the connection is VPN'd in, it's not that fast. But I can still gank the files for you guys by running the cat loop.
So this is what it looks like when it's running.
Yeah, I just, for your information, I just had it print out, this is the domain that I'm sending, but yeah, you can tell that those look pretty odd. So.
Yeah. So, and then if we go back to our server, sorry little phone, you have to deal with it. On the dashboard, we should be able, first of all, we'll go to the main Discover page, and you can see that there's already, this is just the count of packets going across my wire is a deviation from normal. And the dashboard that we have right here, set up for DNS, and you can see it's already getting an uptick that stands out more than others. So this is live data. We sorted it on auto refreshing every 5 seconds. Then as we talk it out, it will actually update itself. And we'll watch the file be stolen. So, now the part that we haven't done yet, and I would like to push this project a little bit more, is that at DEFCON somebody came up and informed me that Pro IDS has some pretty good heuristics where it can calculate that this is occurring and then generate an alert. Using that plus packet beats, there is an article actually that you guys can walk through that you can automate email notification of this behavior occurring as it's occurring instead of waiting for it afterwards.
So I would think that you, like, again, like the code of, subdomains, .google.com, .yahoo.com or whatever, like there was a pretty significant, like once you get over like X number of host names for that domain, like, well.
But this is just for his laptop, right? So
Yeah.
it looks odd for his laptop, but if you're looking at the internet at large, like maybe
Right,
it's a
but
little bit harder.
and you guys are probably at a better choke point to know, to be able to look and see, like, hey, you know what, like nobody ever has like more than 1,000
So
or
we do
100 or
like,
something.
I deal with query floods all the time, like usually compromised servers. So like the point where we start caring, well, the official answer is about 300 a second. The reality is usually we let them chill on about 1,000 a second. Usually 1,000 a second is when we start stepping in, unless it's a very clearly malicious, like just a reflection attack. but it honestly, given our, like, I wouldn't really dive into a lookup of anything. Like, so if you run it at maybe like 500 queries per second, which we're doing less than that.
Yeah, but I'm not necessarily talking about the frequency of the queries. I'm saying, and I'm not a DNS guy, so feel free to tell me I'm stupid. But like looking to say, okay, well, for Yahoo.com, okay, well, we've asked for www, and that's one.
Mm-hmm.
Now somebody asks for mail, that's two. I guess the question is, if you're tracking that to say, like, hey, we've asked for 100 hosts, is like where that starts to get suspicious.
Caching would mitigate it. I think what you're getting at is like caching would help most domains because like Yahoo.com, you're going to get 100 queries for mail, and you're going to get the first one's going to slip out through your internet gateway, and then the next 100 are going to be caught by the caching event.
Right.
This is going to show up because these are a bunch of uncached records for the same domain.
Right. Yeah, when you go to when you go over 100. Or when you go over 1,000 or something, it's like, okay, well, we've made, because
you have to float that value for
Or when you
real
go
long
over
time
Google.
before you
Yeah, when you go over Google, but I mean, Google has a certain set of like unique, it's going to be www.google, mail.google,
I think
whatever.
the
Hey, Tony,
CDN
do you say it was
thing theory.
Pro?
But then you could identify and say like, if you alert it, you can say, well, oh, that's a legitimate
What's up, bro?
CDN. That's
Yeah,
good.
Yes, yeah.
So I mean, we don't usually drill down
It's open
further
source and
It's open
free,
source.
man.
past
Yeah, dude.
a certain top level domain for uniqueness. Like when I use DNS top as my main tool to view, I do a whole data center at a time. Usually it's just a span port that aggregates all the caches, and I just run DNS top and I look for floods, and then when I grab it, I just grab the IP that's querying for it, and then I just block that using a custom rate limiting IP or API. And
But yes, this
we
would be
don't-
detectable if you were looking for uniqueness of domains.
Well, you
It's
have
just
to drill
it's-
down.
And it
past
gets back to the
subdomain.
RPZs they were talking about earlier, because that's like the tool you have to mitigate this, is RPZ, right? Yeah,
Well, I mean, that's once dev.com gets flagged as malicious.
exactly.
And we
But
don't control
to-
that RPZ list.
We were trying to make this so that way anybody that joined the presentation knows, like, we even have a slide on what the hell DNS is, right? So we're trying to, like, baby step you up to understanding, like, everybody in the room understands what's going on right now.
And this is probably the simplest way to, like, the most straightforward way to do this. You could mess with other fields in the DNS packet, and
And if you didn't care about being quiet, you could do it a lot faster.
Yeah. So like some things that have been common in the industry are smokescreen DDoS attacks. So if you know port 53 and all of a sudden you're getting an influx of port 53 and an exfiltration on port 53, would you block 53 and kill all of your DNS? Would you look at that and be handling the inbound flood of DNS and ignore the outbound attack? Like, this happens more often than we'd probably like to admit. And the other point I think that you're trying to capture is that you clearly Def.com has an uber amount of unique FQDNs. But instead of sending a whole file, send, I don't know, database, usernames, passwords, so that way you can have an advanced persistent threat that anytime somebody changes their password, yank the password and send it through an MX record. Very small, very hard. You won't see it.
And you can send it across multiple domains.
Yeah, but these domains
or the
cost
botnet,
something,
or
whereas
the
packets don't.
or the botnet, the command and control aspect of it, like using the Java application.
Oh yeah, if you're just sending that much data,
Just-
then
just
you're
send a
never
small
gonna catch
amount,
it. But
yeah.
the nightmare scenario, I think, for a lot of places is I've got X number of gigabytes of sensitive data, and like how do I make sure that I only lose 5 megs of data, or we start looking at this when we're 5 megs of data in, not when it's every.
And you can
file
do
in the
basically frequency analysis of where your forward lookups are going. If suddenly it's all going to Russia or something, but I mean a proxy server is pretty easy to. There's a lot of ways around that. I mean it's not hard to get a VPS in any country you want to look legit.
And I'm assuming in the wild too, right, you'd adjust the size of your,
Yeah.
because you get some pretty nice clear bands.
Yeah,
right?
yeah, yeah.
You got
I mean, this is
servers in
just-
Russia, don't you?
I mean, the scary thing is that you can do this laterally, east and west, between servers inside of your own environment and start hoarding data into a certain place that maybe you host all of this on a website and you just have somebody externally just browse the site and start getting those files. So now it's port 443 legitimate traffic coming off of your web server that we staged using DNS on your certain system.
And
So
we started-
these are just tools that you guys can use to be as evil as you want.
And we started thinking about odd concepts of how to take advantage of storing data in file names over when Corey and I were at lunch the other day. And we figured out how to get free data storage where they charge you by the file length. just store your data in the file name and upload 0 file length, and then just aggregate that. So on like CDNs and stuff, when they charge you based on file size, you can just store your data in a file name and make the file 0 byte length.
Some DBA somewhere just like felt the crit. He's not sure why.
Yeah.
He tripped over himself on the sidewalk.
Yeah.
And the last piece of information I want to just put in your brain here, and a couple of you heard me say when I was getting some pizza, but all these great info blocks and all of that, super expensive. Do you have one of these at home?
Info blocks, we got them running in our labs. We got.
Yeah, but are you
like
watching,
at your
are you
house.
watching your DNS at your house? To make
Oh
sure
yeah,
that-
yeah. I run open DNS. I don't run open at home. I run open. But yes, I was just saying.
But most people aren't
I watch
thinking
it.
about, like, you're protecting our
I watch it.
offices, our networks and stuff like that, but think
Professional
about it,
tools.
this could be my laptop right now, because sending DNS queries, am I monitoring it right now? Well, I'm not telling you, but if I'm not, like, if I'm not, then you could be stealing data off of my laptop right now, off of whatever network I'm on, or anything. So just keep that in mind, that if you're not watching, this is definitely a viable option to get data out, but it's just as easy as getting data into your computer. So I'll leave it at that.
Some good stuff. Yep. I hate DNS now.
Just lock it all. Did you want to talk about
Lock it
DNS
all
sec?
up.
Because that's
There's really, I mean, everyone will say, like, oh, will DNS help you in this case? No, it won't. I mean, we're exactly who we're pretending to be. We're not pretending to be someone we're not.
Yeah.
We could DNS sec, sign any zone we want and then use it maliciously. It's not like we're pretending to be someone else.
What would help in this case, I think, is
So I had someone ask me that question. One of our network architects was like, so if you could rewrite DNS from the ground up, what would you do differently? And I was like, wow, that's a pretty rough question. Because, I mean, DNS is my job and I'm on the infrastructure team, but I'm nowhere, I don't claim to be Paul Dixie. I don't claim to be smarter than the people who do author it. I mean, I read all the RFCs and stuff, but it's a tough question because DNS was never intended to be the trust link in the chain. It was never supposed to be that. It was never really, I don't know, I think it's just an inherent problem. Same with BGP hijacking. It's kind of like similar to that in the sense that you're abusing trust. And it's just something that I think more people would abuse if they knew it. But it's one of those things I can tell like my manager is probably like, why are you telling all these people how to abuse DNS? Like you're making our job harder. But I don't know. I don't know what I would do differently. It's just a problem that has to exist because of just the way DNS has to function with authority. I mean, unless we went back to the old school way of downloading a host list from a centralized server. Yeah, the host file. That's about it. But that doesn't scale.
So what you have to do is you're a large enough org, so you basically prevent DNS from just happening from anybody, anywhere, at any time. Funnel it towards a central point out to the internet, because the key of this is it has to go to the internet for resolution.
Yeah.
If it hasn't gone to the internet for resolution, it hasn't made it to you guys. So if you can get your DNS infrastructure to like a single point or a single set of DNS servers that are then performing these queries, you can then monitor it. You get your key metrics in your monitoring, you can figure out if it's happening or not. And that's your layer of the onion to help
And we
versus
do
everything
that
else.
pretty heavily. We have monitoring on just ridiculous monitoring. Like my cell phone, when I'm on call right now, actually, I get probably about 500 to 1,000 text messages a day from Nagios for various metrics, CPU load, process IDs, query numbers, the delay in replication time between masters. I mean, every single metric you can imagine we monitor, and we watch really closely. But most of the time, they take care of themselves. But we do watch it, but we only really dive in when there's a query flood, a DDoS attack, or replication fails. Like, we're fairly, hands off, but when there's a problem, we dive in. So unless there's something super suspicious that raises our attention, we don't really...
You guys are far from unique in that, right?
Yeah.
So, I mean, everybody's treating DNS as like, that's just a part of the infrastructure.
And
It mostly works. Don't mess with it or else it'll break. Yeah,
And like our volume, our log volume on our caches makes logging not the most feasible thing. It's very difficult at our scale. We log everything for our auths, but we're more selective about what we log on our caches because the volume is just so much more massive. So that's another thing.
What was it? I was working on an outage, and afterwards somebody sent me the haiku picture. Like, it can't be DNS. It won't be DNS. It was DNS.
Yeah, I had that printed out.
It's exactly the thing.
Yeah.
This is yet another fantastic example.
So how do I even manually validate whether or not it's a good subdomain or not without exfilling the datum?
You can go send a million more queries in the middle of their stream and make them work really hard in order to.
Well, if you go to the website, you could be
obvious though,
compromised.
like you would
With a
just
botnet.
say cat3 is the file name, so let's inject some stuff in there.
Yeah.
Another thing is that unless they have some kind of response policy or checksum, you just drop a couple of random packets in it and if it's an application to build DNS, it would retry usually, right? Your mail server can't get the MX record, it waits a couple seconds and tries again, right?
Yeah.
But still, from a hacker's perspective, this is going to work most of the time.
Yeah.
So.
Yeah.
And then
You couldn't buddy the data stream. That's probably the best you could do.
You got my customers got all the fancy tools that we set up where I know that they have. There's no way I can even see this. I'm just going back and reliving everything. There's no way I can even fix that.
You'd have to have a tool that was.
Or for them to even think that something was odd happening. Nobody ever looks at it.
I guess
It's
you
so
could
weird.
pipe
It's like
it
until
inside.
just right now, there's a total
Pull
blind
that
spot.
traffic, prevent the
I don't even
forward
know
lookup,
that's-
check the
yeah.
forward lookup. But at that point, you're just going to hit that malicious website, and then you could be compromised into the botnet.
There's
I didn't even know the
already
last place you
several
worked
just
would even be able to
awareness.
see that.
Yeah.
So that people don't say, oh, it doesn't matter if they get into my network because they can't
Seriously,
get out.
with all the tools that
Yeah,
But they had
Because
structured
everything at
DNS
the
in
edge
multiple
protecting you from
regions.
getting in,
Even
and
after
then
they
the
still-
good old
they
adage,
still
if they're
fix
in, what are they going to do?
And they also
Move
went dark.
laterally, but then are they going to send the data out? Are you going to see it? If you had 280 days, I can throw random numbers up now, but however many it is, it's a lot of damn days. If you're in your network, that you can say every 5 minutes send 300 bytes of this file, and then send some kind of MX record to say, hey, I need this to this size byte of that file. Or every time there's a change or whatever it is, like you've got time.
For Rackspace, it's not doable in service providers, but for corporations, if you just go dark, you don't respond to DNS unless it's coming from your service provider. At that point, you're
Rackspace got 4 servers.
Yeah, it's a little different depending on which side of the coin you're on, right?
Well, you'd have to block all of your outbound traffic in order to prevent this,
No,
right?
what I'm saying is I could only accept traffic from DNS from, let's say, Time Warner or AT&T. Those are the only ones.
But
that-
those services forward on to an authoritative name server
Yeah.
somewhere, right?
But I'm building my protection there, wouldn't I? Because then the only person I can respond to will be AT&T and AT&T to me.
But then their servers have to go and look for us.
In this example,
Right, but that wouldn't put the issue on me. That would put it on that.
Oh, okay, you're just trying to pass.
I'm just.
Oh,
I'm
okay.
saying.
Oh, I didn't get compromised. You did.
Yeah. So I'm just saying, if I
You let it leak in.
If I work for a bank, which I don't anymore, but if I did, by going dark, then they're the ones that will have the issue.
I mean, it doesn't matter who forwards the data to the hacker, as long as the data gets out. It's just the blame game at that point.
Fair.
I need a beer because
But
that
if
statement you
if
just
it's
said.
written into your contract.
I guess,
you
yeah,
just go,
yeah.
I see how you can shift left.
Yeah.
I like how that's going.
You know what you're saying?
That's smart. Yeah.
But
Great.
Make the provider solve the problem.
Yeah, no, that would work if you're trying to shift blame.
Yeah.
Yeah.
Hey, at the end of the day, the risk is mitigated.
Yeah.
Risk is mitigated.
I say something like this at the party.
The holy grail that would be fun to add to this would be air gap
You were saying
jumping
something about
and
being
capping that
face-
into it. Moving air gap jumping into, so that it would jump air gap,
Because I don't
then
even catch the
DNS
first lookup
exfiltrate
after
from the
that.
other network.
Okay, but it's already out.
that would be.
Here, it's already out.
So that would be the fun part. And a lot of the guys at DEF CON, that was always the talk. They're like, well, can you jump air gaps? And we were like, no, not yet, but we can look into that. And see us next year.
What about this question? Instead of the data being in the subdomain, what if the frequency of request is binary?
Oh.
Yeah.
Yeah.
So you send a pulse of data and then stop, and
Yep.
pulse, just like Morse code.
Yeah.
Just simply making the queries at a certain specified time, at a certain specified threshold, just pulsates. You can send the data out that way too. Or SYN floods.
Yeah.
Maybe SYN floods, there's a pattern to some of these outbound SYN floods that I see, and I'm like, well, maybe it's not just a blind SYN flood. Maybe it's a frequency of just sending the SYN request because there's no SYN act coming back. Like,
And we were also going to do NTP data exfiltration, but NTP isn't as open, but it's still fairly open. We were going to start doing NTP protocol.
You could take this concept and expand it into a lot of other areas.
Yeah.
Yeah, I mean, how many orgs here simply block outbound 53, period,
Yeah.
and say route all queries to my DNS server? I mean, I can think of places on my network that don't have that in place. Like there are server nets that go, hey, I want to send a packet on port 53 to 8.8.8.8 as validation for something. Absolutely. please do that, because you need you to check to make sure that DNS is functioning properly.
If dig doesn't work on your box, most sysadmins will tell you it's broken. And you know what I mean? Like, if you can't dig something, they're going to be like, what the hell?
Right.
And
how do I know what gravity
yeah,
is?
what's my job? Right? So dig has to work pretty much always on a server. And that's all you need.
This needs to be a learning experience as far as how do we architect DNS to make this mitigatable, period.
And it's inherently how DNS has to work, really. I mean,
Yeah, but there can be a tool for it to.
I'm still thinking like,
this out.
if Akamai fronts somebody else, and Akamai is a responder on behalf of somebody else,
yeah.
and Akamai only responds for the domains and subdomains that another bank corporation has them paid for, they won't respond to anything else. And if they did, it will be on them because it will never get to the corporation behind them.
But we don't need Akamai. I mean,
That's what I'm saying. It depends on which side of the coin you're on.
yeah.
If my job is to protect big companies,
Yeah.
going to somebody else that will do your responses, you are kind of detaching yourself from that situation. Now, Akamai has a big problem to figure out.
Yeah. I don't think there's no silver bullet other than whitelist and black.
provides that service?
Akamai, LimeWire.
Yeah, like Cloudflare, I think, does manage DNS with security enhancements or something. It's
So you-
basically just RPC.
Your security posture would have to be to make sure that every organization can't send DNS out except for this list of approved choke points that allows you to do the monitoring. Whether it be Akamai, your own server, whatever it is, that's the only true solution here. Even though that doesn't solve the problem, that helps you at least identify. You can block 53 from everything except for these approved domains.
And that's what I was wondering, right? It's just you're not fixing the problem. That's not what I can do. But what I can do is have somebody else take that hit. If I
Passing the buck, bro. Hey, I'm not this dude.
It depends. If I was working for Akamai, I would be stressed. But now I'm saying like I can give that situation to somebody else. I don't know how I will stop the outgoings.
Yeah.
That's what I'm.
I mean, I think of it from the red team perspective. I don't really care who takes the fall. I can see you're thinking of it from like the blue team side, where you're like, who's going to be on the line, who's going to be on the hook for this.
Well, not even that. I'm just thinking as a businessman, right?
Yeah.
It's not red team. I'm just thinking as a businessman. How do I make my company not be compromised?
But even if you ship the
My business
liability
is
at
blue
that
team,
point,
so.
the customers are going to know that your company had the breach, regardless
Yeah,
of
'cause the data's gonna
who
get
the
out.
lawyers sorted out. You know,
They're not getting it through DNS, they're getting it through some other way.
Yeah.
Like, I've seen
Malware.
people use like text records and stuff.
Yeah, oh yeah, we see
Yeah.
botnet command and control structures
Yeah.
using text records, things like that.
But I've used text records. There's a few plugins for getting payloads down to boxes that only have access to like a 53, and it's only a cached name server. So
Yeah.
just querying text records, getting the data that way, and then base 64
Yeah.
coding it back into a payload.
I think there's like Docker or Chef or some of that stuff uses DNS manipulation for that kind of stuff.
Oh, really?
Or I've heard of things doing
That's
it.
cool.
I haven't really looked into it, but
There's a for red team tools. There's like Cobalt Strike. They've got a DNS module you also check out. Metasploit's got some stuff, and then somebody made a fork of Metasploit with a DNS cat from Spool Security, and they merged it in so you can actually have an interpreter over a DNS cat tunnel.
nice.
So yeah, there's so many ways that people are using it, and that's what makes it even harder to detect. Because like you said, I mean, base 64 decoding would maybe catch like a little bit, but there's so many other stuff that people are. But it seems like, you know, like there's people that were doing kind of heuristic detection of people registering domains for botnets because they were looking at domains that were being registered. But this is hard because it's like you just have to register one malicious domain and it could look totally legit, like the one that you'll have.
The life of the domain could be something you can key on though. If it's
very
if it's
new.
fresh,
Yeah.
and that's probably less trustworthy. If it's been there for a while, then some of these RPZ would catch it. So there
But I
would
mean,
be a
yeah,
period of
maybe
time
you
that
could
distrust
based on-
in
You can
domains.
aggregate a
something
list of the
you think
entire
that
internet and
people
monitor
have
that for for cheap.
Was it
That's-
sender based for like mail? You could do
Yeah.
something like that for DNS too.
We've bypassed Lookups before doing phishing engagements where we registered a like a typo domain of a legitimate company's
Yeah.
domain and registered for like 3 months. Let it sit there
Yeah.
so
Oh,
that
yeah.
we actually cloned their website and put it on there so that anything that was scanning it for reputation-based scoring would score it equal to the legitimate website, thinking that it was just that company actually registering the domain.
In case, like I've typed.
Right, typo, right. Then when it became time for phishing, load the payload in there and send it, and it went through Lookup and all that stuff because it was past the reputation.
See, and this is the reason why I hang out with him, because when he talks to stuff and go in the lab, I'm like, all right, look at what this guy was told us they could do.
Yeah, but this
And
is
then
like-
all the team's like, what?
Yeah.
Those are
Well, how
really
we beat
cool.
that? Let's figure out a way, because this dude's dropping knowledge cut left and right over beers. Get him drunk, he'll tell you a lot more. A
I
lot
heard
more
there'd be
stuff.
pie and punch.
Yeah.
No, this is cool. Good work, Joe.
Yeah, this is awesome stuff, man.
Definitely the right direction.
Eye-opening stuff.
The tool looks really cool.
It was just three guys messing around, trying to one up each other, and went from one thing to another thing,
Yeah.
and then we're like, how can you get data back in? Can you get it all? I mean, it was literally just, we were sitting there at a coffee shop over a hookah and just like theorizing what
You guys all
happened.
met at Rexface? Because me, him, and him are all from Rexface too.
Yeah.
99 to 2000 to 2010.
Yeah.
And we did the same
Tony
thing
and I
back in the
were
day. Lots of people that have brain power that share stuff.
Oh yeah.
Yeah, we were just playing around and like
Yeah.
I got so like the talk got accepted at DEF CON and we didn't even have it. It got accepted with just an outline of what I thought we could talk about. But absolutely nothing.
Oh, said he stepped off the drinking. Oh,
I was like,
accepted.
well, we better pull something together, and so we did, and it turned out pretty good. So this was just us kind of playing around in a couple afternoons. So imagine what a nation state like the NSA can do or is doing if a couple of guys can just throw something together like this in an afternoon. So
We want to be caught with what we're doing.
yeah,
We're making it bloody obvious right now.
Or like a store
Casting
module
fun.
for cat picture detection or
Yeah.
base 64 decoder.
Yeah, but think about the organized criminals or the government sponsor teams, right? The ones that are out there to get paid to do it. Yeah, the APT, with the ones we call APTs.
They got way more money and way more time than we have, and they knew about this 30 years ago.
I had a buddy who was Air Force, and we used to drink together a lot. And the stories that would come out once we'd start drinking were always pretty amusing.
So you're saying next OWASP meeting,
Beer?
special lunch? Yeah, beer.
Yeah.
Nice.
Well, cool. Well, thanks, guys.
Oh, wow.
Fantastic.
Great stuff.